I'm Richard with EV4U Custom Conversions. And in today's video, we're going to talk a little bit about motor selection. It's a common question we get, what motor should I use? And it's also one of the areas that people can make a costly mistake by mismatching the motor to their vehicle and the intended use. So today we're going to look at 4 different motor controller combinations. First, we're going to look at the AC50, which is made by High Performance Electric Vehicle Systems. It's a 3-phase AC induction motor. These first 3 are made by High Performance Electric Vehicle Systems. The AC50 is typically mated with the Curtis 1238 controller. It has a maximum input voltage of 130 volts. Now, the maximum voltage then is going to determine your maximum pack voltage. And it has a maximum current output of 650 amps. And of course, that's going to determine your cell ratings. So you're not going to be using a 60 amp hour cell with this type of setup. I mean, there's situations where you could, but not in a series string. And then another important factor in this, probably one of the most important factors, is the manufacturer's suggested or stated maximum vehicle weight. Now, we have experience with these motors, except for the latest one, which is a new one. We haven't actually put this in a vehicle and tested it yet, but we've discussed with the manufacturer tests that have been done. And this is going to fall in line with what I'm going to say as far as the High Performance Electric Vehicle System motors. And that is, they rate them kind of high. So when they say 3,500 pounds, from my experience, I'd say that would be the maximum, absolute maximum. I'd say if you stay 500 pounds under, you'd be a much happier camper. For instance, our Karmann Ghia, which runs the AC51, is 2,200 pounds. That's a good feel for that car. When you're up at 4,000 pounds, it feels quite underpowered. So anyway, the AC51, rated up to 3,500 pounds, produces 76 horsepower and 120 pound-feet of torque. And it weighs 115 pounds. That's the motor itself. And the cost, and this is for both the motor and controller, the cost is going to be for the 2 items, the motor and the controller, in each of these instances. As of this current time, January 2018, they're $39.50, and that's for the motor and controller, like I mentioned. The next one we'll discuss is the AC51. It was designed to be matched with the 1239 controller. The difference is that it's 170 volt maximum input, and it's 500 amps. Now, if you do the math, you'll see that these 2 put out the same amount of power. Okay, so even though one's rated at 170 volts, the other's rated at 130 volts, 650 amps, 500 amps, do the math, they basically put out the same amount of power. They were just designed around different controllers to allow for different pack voltages. And it has a greater ability to cool itself, and so you can run 4,000 pounds. Like I said, my recommendation would be 3,000, 35, 3, so forth. Rated at 88 horsepower, 108 pound-feet of torque. It weighs 115 pounds, $4,700. The last of the High Performance Electric Vehicle Systems offerings we're going to discuss is the AC35 x2. It's basically 2 AC35 motors Siamese together. And they use 2 controllers. They use 2 of the 1239s, 170 volt max in. So each controller can pull or put out a maximum of 500 amps times 2. So your pack's going to see a draw of 1,000 amps. 3,500 pound maximum weight. Like I said, I think 3,000 would be a better figure on that. These motors tend to run hot, especially at the higher end. And that's because it's, you know, you can put 1,000 amps through that motor that is same diameter as these others. It's longer, still has the same cooling capability, but has more heat generated. So we'll talk a little bit more about that in another video. We'll look at the motors and discuss some of those idiosyncrasies. But here's what makes this motor kind of popular, and this is what we use in the Miata conversions, because it's basically 8.5 inch diameter, 21 inches long. Not a, you know, pretty nice little motor, but it puts out 165 horsepower and 189 pound-feet of torque. And the Miata, for instance, they're a 2,200 pound car. When you're finished with the conversion, they're, you know, about 2,500 pounds. So that's pretty good performance, and it works good in a lighter car like that. 150 pound motor, a little more expensive. Remember, you basically got 2 motors and 2 controllers. I mean, it's one motor, but it's 2 of them Siamese together and 2 controllers. Thus the higher price tag, $8,900. Now here's the new motor on the block, but not the new kid on the block. This Hyper 9 is made by NetGain Motors. NetGain Motors won fame by producing motors such as the Warp 9, which at one time was probably the most popular series wound DC motor on the planet. That thing was a great motor. You could pump out almost 200 horsepower with the right setup. They kind of went away with the advent of the low voltage 3-phase AC induction motors from High Performance Electric Vehicle Systems, and so you don't hear too much from NetGain for a while, except for the racing world. You know, all the world's fastest electric cars were running the NetGain motors. So like I said, they were quite well known at one time, and I think they're going to make a comeback. Their new motor, labeled the Hyper 9, is a permanent magnet synchronous reluctance AC motor. And I'm not going to go into all the details of that, but what you get is a light motor. It's in an aluminum case, so it dissipates heat pretty well. Has good numbers, 120 horsepower and 170 pound-feet of torque out of a 90-pound motor. But again, I wouldn't recommend going over, say, 3,000 pounds with that. Anyway, maximum input voltage, basically the same as the Curtis 1238. It's 132 volt max, 760 amp output, and priced nicely at $4,150. So this is a small motor in overall dimensions, has good numbers. It's going to be great for certain applications. We're probably going to stick one in our little red VW Bug. Replace the Impulse 9 that's in there now. So anyway, this is just some of the stuff that, you know, that you're going to be comparing and looking at when making your motor selection. Big one's going to be vehicle weight. Another one's going to be, you know, you want to research all your specs on the motors. So you want to make sure that, you know, you have enough length for the motor, you got enough room for the diameter of the motor. The motor's a certain length and a certain diameter, you might be running into a cross member or some other issue. If it's a front engine transverse mounted, length becomes an issue in a lot of those applications. So you want to check all that. You also want to check the power graphs and see, where do these motors make their power? Some of them favor the high end a little more than others. And so based on the type of car it is, the type of driving you'll be doing, that's consideration also. And another big one, like I mentioned, the temperature rating. This has a lower temperature rating, the Hyper 9, than the others. These are all rated high performance electric vehicle systems motors. They're rated at 180 degrees C. This is only rated, I believe, at 150 degrees C. And then the continuous power rating. That's something to look at. All these figures, these are the peak figures, the peak horsepower, the peak torque. And that's fine and dandy. But make sure that your continuous rating is sufficient enough to, propel the vehicle and the load that you want to propel. And again, this maximum weight, I don't know if I mentioned it earlier or not, but that's not just the curb weight of the car. We're talking about the weight after conversion with driver, passengers, and any anticipated cargo. One of the things I see people do most often is they undersize the motor trying to save money, or they forget to add in passengers and cargo, and they tend to limit things because it's being overloaded. Motors get hot, cuts back their power. So best to do your homework. So this is kind of an overview of some of the things that you would want to consider when making your motor selection. Remember, this is all part of a big picture. This all affects other items, and other items affect this. Most notably, your battery pack selection. So, until next time, I hope this answers some questions. If you have any additional questions, please address them to info@ev4unow.com. Be happy to answer those. And until then, I thank you for watching. See you next time.